factoring polynomials completely, you need to put your thinking caps on. Okay? You're going to have to run through a sequence of steps to decide, can I do this first? If you can, you'll do it. If you can't, you move on to the next step. Okay, so the sequence is shown right here at the top in a kind of like a diagram. It says, first thing you're going to look for, is there a GCF among the terms? So now, just like you did in those first 12 problems for today, you would look to GCF them. So you found the GCF and you factored them by GCFing. Sometimes you can't GCF. So if you can, you do it, and then you move on. If you can't, then you just move on to the next thought process, which next thing you're going to say is, how many terms are there in the polynomial? So if you could GCF, you're going to be looking at the other polynomial that you get that's a factor with that GCF. So whenever we GCF, even if we can, if it was a 3-term polynomial to start with, the other factor you get that is in those parentheses next to the GCF is still a trinomial. So we're going to look and see how many terms are there, because that's going to help us decide if it's 2 terms, is it one of those special binomials? It's got subtraction. Does it start with a square? Does it end with a square? Because we know how to factor those. If it's not, then you're going to say, I guess I can't factor it. If it's a 3-term one, then you're going to try if A is equal to 1, then you can just do the diamond method. If A is not equal to 1, then you're going to have to do that diamond method and the factoring by grouping method and see if you can factor that trinomial some more. If it's a 4-term polynomial you have, you're going to try that factoring by grouping. Make 2 groups of 2 and see if you can factor it that way. Okay? So what's the first thing we're going to look for?
If there's a GCF.
Yep, we're going to see if we can GCF it. Can we find a GCF? That's the first thing you're always going to look for. And and if you can find a GCF, then you're going to go about doing that first. Okay, what's the next thing? If the polynomial has 2 terms, what special product should you look for? What did we call that?
Square.
It was, what kind of a polynomial has 2 terms?
Binomial.
Binomial, and it has to have what?
A square.
Squares at the beginning and the ends. And what does it have to have in between? Subtraction. So remember, that's called the difference of perfect squares. Difference of perfect squares. So you're going to look to see, is it a subtraction? That's what the word difference tells us. And are the 2 terms perfect squares? If the polynomial has 3 terms, what should you check for? Can you use the diamond method? Yeah, can you factor it into 2 binomials? So what we're going to say is, because of the way that we learned how to actually factor these, we're going to say, can it be factored with the diamond method? So we're going to set up our diamond according to whether A is 1 or A is not 1. We know what we have to do in either case. So can it be factored, not it factored, can it be factored with the diamond method? You're going to check it out and see if you can do that. Okay, and then if it has 4 terms, what kind of factoring are we going to look to do? What do we do when there are 4 terms? Factoring by grouping. Factoring by grouping. So you're going to set up the 2 groups, and you're going to try and factor it that way. Now, just like has happened in the last week or so with our factoring, once we learned how to factor, then we've had some times when polynomials were not factorable. So I say in the homework of those 12 problems that you have for homework, I say 3 are not factorable at all. You can't do anything to them. You try to GCF it, you can't. It's a 2 or a 3 or a 4 term, and it can't. One of those things can't be done to it. Then you just say it cannot be factored at all, but there's only 3 of them, okay? So factor each polynomial using the sequence chain as a guide. This is where we're going to go to our work page. So go to the work page. We're just going to come back here and put our answers on that page. Okay? So we have the polynomial 3x squared minus 20x plus 12. What's the first thing we're going to look for?
The GCF.
GCF. Okay, can this one be GCF?
Yes.
Okay, what would be the GCF?
No. It doesn't have GCF.
Can 3 go into itself?
Yes.
Yeah, I'm going to go into 20?
No.
No, then I don't think 3 can be a GCF.
So there's
Anything
no,
else?
There's no GCF.
One.
One.
One, but remember if it's only one, then we say we're not going to try and do it because we won't really get anywhere. We do use 1 as a GCF when we're factoring by grouping though. You're right, right?
We don't have a GCF.
Okay, so we're going to say right here, no GCF. We have to go through that thought process. We have to try. If we can't, we say no GCF. Then we go to the next thing which says how many terms does it have?
3.
The 3-term polynomial. What do we use for 3-term polynomials? Diamond method. So we're going to do A, B, and C. Okay, let's go. Oh, we got to change it to add the opposite first, don't we? Plus a negative 20x plus 12. Now we'll identify our A and our B and our C. So what's our A value?
3.
B is,
Negative 20.
and C is
12.
12. Okay. So A is not equal to 1. That means not only are we going to have to do the diamond method, but what else?
Multiply that to the C.
No, factoring by grouping. We have to do the diamond method and the factoring by grouping for this one. And we are going to have to multiply by C in our diamond method. So we're going to set up our diamond. And we're going to have to take 3 times 12. 3 times 12 is? 36. Okay, so we need something that will multiply to be 36 and add up to be what? Negative 20. Okay? Negative what? Negative 2 and negative 18. You guys agree? Negative 2 times negative 18, would that be positive 36?
Yes.
Would those two numbers add up to negative 20? So let's take a look at them. Would those add up to negative 20?
Is it mattering whether the 2?
Does it matter which one? No, it doesn't matter which one's on which side. Okay? So, we're going to rename now our 3x squared plus negative 20x plus 12 as what?
3x squared
Plus negative 2x plus negative 18x plus 12. Go back. So the only thing that gets replaced is that, right? Everything else stays the same in the polynomial. So the negative 20x gets replaced with that negative 2x and that negative 18x. And now we do factoring by grouping. Okay, so what's our, we'll make these two a group and these two a group. The GCF of our first group. 1x, okay? So just x, can I call it?
Yeah.
Okay, what's the result after we factor an x out of 3x squared? 3x or 3x squared?
3x.
3x. What's negative 2x divide out that x?
Negative 2.
Negative 2. Okay, so we factored our first group. What's the GCF of our second group? Yeah. If we try 6, we're going to get a negative 3x. What do we want?
The same.
We want a positive 3x, don't we? So let's just go right to saying, let's do a negative 6. How about any x's? No, there aren't any x's in that 12. So negative 18x divided by negative 6? 3x. 12 divided by negative 6? Negative 2. We need these guys to match. And they do, don't they?
Yeah.
So that's one of our factors. 3x plus negative 2. What's the other factor?
X plus negative 6.
X plus negative 6. Good thing you all did so well on the quiz, huh? And what do we do cleaning it up?
3x minus 2 and x minus
3x
6.
take away 2 times x take away 6. There was no GCF, so that's our factored name. Right.
4 Or at the beginning step, can't you have 3x to the second and minus 18x, so then it can be, if you simplify it down.
Yep, you can do it, and we'll still end up with the same factors, don't you? Yep, so yes, those can trade places. It could be 3x squared plus negative 18x in one group, and negative 2x plus 12 in the other group. And it should still, in the end, work out the same, to be the same factors. One,
Did all that work out from this page?
oh, well, now next time move over to the other one. Okay, now let's go back onto our first page and put this factor name. 3x minus 2, x minus 6. Now, if we had been able to GCF it, we'd have to include the GCF out in front of that too. We would have one more factor, but we couldn't GCF this one. So this is kind of a lot like just what we've just done. You're gonna feel like, oh, wait a minute, LeBrand, you just said we were doing something new. But we are, but we aren't. We're still using all of our factoring methods, but we have to start with always asking ourselves, can we GCF it first, okay? Because, let's look at that next one, number 6. Tell me something. If you were just going to start this right now, let's pretend this had been on the quiz yesterday. Would you have said you could factor this?
No.
That's subtraction. It's a binomial. What are you talking about?
Two.
And the 2x squared is not a,
Square.
it's not a perfect square. Yeah, it's not a square. Is 50 a perfect square?
Yes.
No, it's not.
No.
No, it's not. It looks like it. It's such a nice number. It looks like it is, but it's not.
Get a GCA.
So it doesn't, even if just one of them isn't a perfect square. So right now it doesn't look like, you would stop and you would say, on yesterday's quiz, you would have said this is not factorable.
So
But it is. What's our first thought going to be today? Can I
GCF,
GCF it?
yes.
What would be the GCF of this polynomial?
2.
2. So we're going to GCF it first. 2. So what does 2x squared divide out that 2?
X.
Just x?
X squared.
X squared. Subtract
Or minus 35.
25. Now notice I didn't change it to add the opposite because I want to keep it so that we can tell whether we can still factor it yet some more or not. Okay? So could we stop now and say we're done? No, the next thing we're supposed to say is it a 2-term, 3-term, or 4-term polynomial that I got as a result? What did I get? 2-term. So I have to ask myself this question. Is it the difference of 2 perfect squares? It's subtraction. X squared is a perfect square. 25 is a perfect square. So can this be factored?
Yes.
Yeah. So what's going to happen is we're going to factor this. We're going to put an arrow like this so we don't forget to bring it down. We don't want to forget that too. It's part of the factored name. We can't forget it. So we put an arrow so that you don't forget it. And then we're going to do the work that we would do for the difference of 2 squares. We take the square root of x squared. We take the square root of 25. And then one of them has addition, the other one has subtraction, right? Isn't that what we did?
Here.
Square root of x squared is
X.
x.
5.
Square root of 25 is 5. So this becomes x plus 5 times x minus 5. So we factored our factor that we got when we GCF, and then our GCF has to come down and be in front. Because remember, the factor name has to multiply back out to where it started. And eventually it has to get back to where it started. So if we FOIL x plus 5 times x minus 5, we would get the x squared minus 25. And then if we took that times our GCF of 2, we'd get 2x squared minus 50. We'd be back to where we started. So it has a 3-factor name in the end.
Looks like 2.
Okay, let's go to the front again. Let's go to that other page again. And let's put that as its factored name. 2 times x plus 5. Or you could have the x minus 5 first. It doesn't matter who's first. But if you leave the 2 up, I can't count that right. So don't forget that the first thing you're always gonna do is try to GCF it. If we can, that becomes part of the answer in the end. Any questions? Okay, we got one more we'll practice together. Go back to the work page. On the back side. First question you're gonna ask yourself today is, can you GCF it?
Yes.
All four terms, we're gonna look for something that can be divided out of all four terms. What is it? 2. 2x, right? Okay, so we're gonna take a 2x out of all four of those terms. 18 divided by 2, 9. X to the fourth divided by x.
6.
X to the third. We're dividing, so we subtract, right? Okay, plus
6.
12 divided by 2 is 6.
Square.
X cubed divided by x is
Square.
x squared. 6 divided by 2 is
3.
3. X squared divided by x is x. 4 divided by 2 is
2.
2. X divided by x,
Cancel out.
they're gone. Yeah, they cancel out. Okay. Now, before you move on, here's what you want to do. You want to look at that and make sure that you couldn't have used a bigger GCF. Is there anything that it divides out of 9, 6, 3, and 2 other than 1?
No.
Because sometimes you might not get the biggest number, and so you always want to double check. No, there isn't. How about, do all of them have some x's still? No, the 2 doesn't have any x's, so we know we took out enough x's also. So we got a good GCF. What are we going to do with that GCF? We're going to put an arrow so we don't forget about it. Put a big arrow there so you don't forget about it, because you will forget about it. Okay, we have a 4-term polynomial, don't we? What do we have to do when we have a 4-term polynomial? Factor by grouping. So let's make our groups. We don't have any subtraction, so we're going to say the 9x cubed and the 6x squared can be a group. And the 3x plus 2 can be a group. Okay, what's going to be our GCF for the first group?
3x.
3x
X.
squared. 3x squared. 3x squared can be divided out of both of them. 9 divided by 3, 3, and x cubed divided by x squared
3x.
is x plus
2.
6x squared divided by 3x squared,
2.
2. Bring down our addition sign between the groups. What's the GCF of the second group?
1.
It's just 1, isn't it? Do we have to put that 1 there? Yeah, we do. It's important. Well, if it's just 1, nothing changes. That stays 3x plus 2, doesn't it? Trey?
What do we do with the 2x now? Because we have.
Okay, let's finish this first. Let's just keep working with this one, and that 2x is coming, it's going to join us at the end, remember? Okay, so the one that they have in common is 3x plus 2, so that's one of the factors. And the other one is 3x squared plus 1. And then we need the GCF in front of it. So 2x, 3x plus 2, 3x squared plus 1.
Where do you take the 2 from? From back up there?
From our GCF in the beginning.
And then it goes down there?
Yep, it has to come down and join the answer in the end.
And that's what GCF is 2x?
This 2x was a GCF, it's still a factor. And then this is the result that after we did GCF it, now we factored the result, and there's its factored name. So all of those are factors. Okay, so let's go to the other sheet and put its factored name on there, okay? So 2x times 3x plus 2 times 3x squared plus 1. Okay. So today in your homework, those 12 that you're doing, 9 of them you should be able to do this to, some of what we just did. There are gonna be 3 of them that you're gonna look and see if you can GCF it, and you're gonna say, nope, can't GCF it. Then you're gonna look to see if it's a 2, 3, or 4 term polynomial, and you're gonna try the method for those, and you're gonna say can't do it. You're gonna either decide that it's the addition instead of subtraction of binomials, or maybe it'll be a trinomial that you set up the diamond, and no matter what you do, you can't get the diamond to work out. And same thing with, even if it was factoring by grouping, I don't think it'll ever get to that point. I think you would be able to, if you can factor it by grouping, you'd be able to get there right away, so. Okay, so let's see how she loosely favored to get started on that homework.